So for this question, it says Captain Jack Sparrow sails for 10 hours at a speed of 14 knots, which is nautical miles per hour, at a heading of 72 degrees north of east. And then he turns to a heading of 57 degrees north of east and travels for 2 hours at 11 knots. Find its position north and east of its starting point and assume that the Earth is flat. Okay, so I kind of have a drawing of the boat up here showing you a few pieces of information. I got the 140 miles by taking, it took 10 hours and he was traveling at 14 nautical miles per hour. So he traveled 140 nautical miles because every hour was 14 miles, so 100 or 14 times 10 is 140. And then he turns and he travels for 2 hours at 11 knots. So 2 hours at 11 knots would give me 22 miles. So this one up here is going to be 22. And this is 57 degrees. So the question is, where does he end up? What's the resulting point? Okay, so I have these two vectors drawn, one in green, one in red. We know this one is 22 nautical miles. The angle is 57. We'll switch up to green here. This one we figured out was 140. And so the question is, where does he end up? Well, just like every other vector problem, we're going to add the x component and the y component of each vector. So we're going to figure out the x1 and the y1 of the green, and then we're going to figure out the x2 and y2 of the red. Okay, so let's do that using some trig. Let's start with the green, and we'll give ourselves a little bit more room here. To figure out the x, we're going to use cosine, so it's going to be cosine 72 is x1 over 140. And so we take 140 times cosine of 72, and I get x1 is 43.26. Alright, so that's the x component of the green vector. The y component would be, we'd use sine because it's opposite in hypotenuse. So we go sine 72 equals y1 over 140. And so we get the y component of this vector is 133.15. Alright, so we have the information we need from the first trip that Jack Sparrow took for that first 10 hours. Now let's look at the last 2 hours of his trip. He turned and is heading at 57 degrees, so let's figure out the x component and y component of that. Alright, so cosine of 57 is adjacent over hypotenuse. So we take 22 times cosine 57, and we get the x component of this one is 11.65. Alright, and then to figure out the y component, we're going to be using sine. And that's because we're doing opposite over hypotenuse again. So it would be y2 over 22, multiply by 22 on both sides, and we get y2 equals 18.66. Okay, so what we have here is we've got two vectors that we're going to add together. We're going to combine the x's, we're going to combine the y's, and we're going to have this new resultant vector. So I'll switch up colors. Actually, let's use our straight line tool. That looks good. And let me give myself a little bit more room here. So we're going to have an x and a y, and it's going to have a resultant vector like so. So the x component is going to end up being 43.26 plus 11.65. Each of these trips affect the x component in this much. So the y component is 133.15 plus 18.66. Okay, so let's add those two together. We get 54.91 for this. And we get 151.81. So, the question asks, it says, find his position north and east of its starting point. Assume that all practice, so blah, blah, blah. So, he ends up being 151.81 miles north of the starting point, and he ends up being 54.91 miles east of his starting point. If it asks for how far away is Captain Jack Sparrow, you would figure out this, but it's just asking how far east and how far north. So that is it for that problem.